It would be very helpful if you first try to solve the problem yourself before watching this video.
Question 237. The function g is continuous for closed interval from -1 to 3 and differentiable for open interval from -1 to 3. If g of -1 is equal to 3 and g of 3 is equal to 11, which of the following must be true? Okay, let's look at part 1. There exists c where c is between -1 and 3 such that g of c is equal to. Part 2, we have there exists c where on the same interval such that g prime is equal to 2, right? So let's think about this graph, the graph of the function g. G of -1 is equal to 3 and g of 3 is equal to 11, right? So we could have, here's x-axis, here's y-axis. When x is -1, y is equal to 3. So let's say here's a 3. And when x is 3, y is 11, right? So when x is 3, let's say here is 11. So y is 11. So we're just gonna graph the function g roughly. We could have this graph, right? Function g is continuous and differentiable. So far so good? So let's check the part A, if this is true. It says that there exists c. c is between -1 and 3. -1 and 3. Such that function value g of c is equal to, right? Well, actually, this statement has to do with the intermediate value theorem, right? In order to have c between these two x values, the function value must be between 3 and 11, right? It has to be between these two function values, right? So first one is not true. Does that make sense? If g of c is not 2, but let's say this is 5, then this is true, right? Because if a function value is 5, which is between 3 and 11, then let's say 5 is here, then there exists c between -1 and 3 such that g of c is equal to 5, right? But since 2 is not between 3 and 11, this is not true. So this is false, okay? Now let's look at part 2. There exists c where c is between -1 and 3 such that g prime is equal to. Well, this statement has to do with the mean value theorem, right? When the function g is continuous and differentiable, then we can apply the mean value theorem, and the mean value theorem guarantees that slope of this secant line is equal to slope of tangent line at some value x, and that x has to be between -1 and 3, right? So let's find the slope of a secant line. We're going to draw secant line using ruler. So hang on 1 second. Okay, so that's our secant line, and slope of the secant line, y2 minus y1. So 11 minus y1 3 over x2 minus x1, 3 minus -1, right? So this is 8 over 4, which is equal to 2, right? So slope of this secant line is 2. And there must exist tangent line at some point between -1 and 3. Let's say it looks like it has to be somewhere here, right? This is our tangent line. And this tangent line, slope of this tangent line is equal to 2, right? Because they're parallel. So this c must exist between -1 and 3. Well, actually, there's one more tangent line here, somewhere here, right? So this value is also equal to c between -1 and 3, right? So we have 2 points c between -1 and 3. So this is true, right? So this is true. So the answer has to be B, right?